and welcome to today's lesson on similar shapes, missing sides, a little bit harder. Okay, so let's have a look at this first question. Now, if you've seen the first video on similar shapes, you'll know that the most important thing about similar shapes is finding that scale factor, and we've got to do this by finding a similar pair of sides. So if we have a look at this first one, let's have a go at this first one. So this first one is example 1. Now the problem with this one here is, first of all, it doesn't say these shapes are similar. Okay. The second thing is, you notice that it's kind of connected and like upside down. It also always looks like sand scales, doesn't it? So let's draw this one out. Now the thing is with this one, because these two lines are parallel, it means that this angle here is the same as this angle here, and that this angle here is the same as this angle here, which means that we've got from congruent triangles, we've got two angles which are the same, and a side in the middle which is the same, which means these shapes are congruent. Which means that these shapes are similar because we've got two angles the same and a side here. We know that they're going to be similar. So let's draw some of our detail onto this. So we've got 3 over here, we've got 4 over here, we've got 6 here, and we've got x over here. And we're trying to find out what x is. Now, the problem we've got with this here is that yes, we've got two similar shapes, one on the bottom and one on the top, but we need to make sure that we've got the similar shapes next to each other because it's easy. Now you notice that this angle here is the same as this angle here, so I can't just move it down. What you've got to do is you've got to take this shape here and you're turning it round. So I'm turning all of this shape around to make this angle on the right and to make this angle on the left. So let's take that, and you're turning this one round like so. And if I turn it around, I end up with a triangle here like this. And I have this one here on the left-hand side, and I have this angle here on the right-hand side. I've turned that round, which means that this 3 is now on the right-hand side, and the 4 is on the left-hand side, like so, because I've turned it around. Okay? So that is tricky there. Now, once we've got that, this becomes pretty easy. It's just very similar to the ones we've done before, or the ones you've done in the first video. So the first thing I do is I find out what the scale factor is. So my scale factor. And my scale factor is always my larger similar side divided by my smaller similar side. Now in this case, so if I ignore this top bit now, because I've turned that round, haven't I? So what I'm looking for is the sides in my similar shapes, which I know both the lengths of. And in this case, it's going to be these, isn't it? So this 6 and this 4. These are my two similar lengths that I know. So they're not the same lengths, but they're similar in terms of the side that they are. And so to find out my scale factor, it's my larger similar side divided by my smaller similar side. Brilliant. So in this case, that's equal to 6 divided by 4. So 6 divided by 4, I can do this on my calculator. Do it not on your calculator. 6 divided by 4 is equal to 3 over 2, or 1.5. So I know that this one here is 1.5 times bigger than this shape here. Brilliant. Now I've not finished there, because remember, I'm trying to find out what this x is here. I'm going to do this in a different colour. So I'm trying to find out what this x is. So if I know that this shape here on the left is 1.5 times bigger, then what I need to do is I need to times the similar side by the scale factor. So in this case, I know that this triangle here is 1.5 times bigger than this triangle on the right. So to do that, it's going to be 3. So, if I want my larger similar side, make it really clear for you, my larger similar side it's going to be equal to my smaller similar side times by the scale factor, which in this case is 1.5, but I'll do that in a second. So in this case, it's going to be equal to 3 times by 1.5, and 3 times by 1.5 is equal to 4.5 centimetres. So this one here, x, is equal to 4.5. Brilliant. So, let's have a go at this next question then now. So pause now and have a go at this one here. So pause now and have a little go at that one. Okay, so let's have a look at this one together then. So, in a very similar way, the first thing we need to do is to turn the shape around, don't we? So let's draw it first. This is example 2. So we've got this part here. I think I called it a sand scales before. It's actually an hourglass, isn't it? We've got 9 there, 9 centimetres. It's A, B, C, D, and E. We know that this length here is 7.2 centimetres. We know this length here is called 5.2 centimetres. This one here is 6. Got this one here at the bottom, which is 9. Okay, brilliant. So we know that these two shapes are similar because this angle here is equal to this angle here because of congruent shapes. So that's like the Z angle, isn't it? And this one here is the same as this one. So what I'm going to do is I'm going to take this shape, exactly the same, and I'm going to turn it round like so. I'm turning the shape around. So instead of E being on the right this time, because in fact, let me show you. If I turn it like that, okay, that's how I want it. So E, notice, is on the left there when I turn it round. So I'm turning the shape around, and E is on the left there with that double one, and D is on the right with that single one. And this 5.2 is now on the right hand side, and the 6 is still on the bottom there like so. So I've rotated this from the top round, and that's always your starting point with these ones that look like this shape. Okay, so the next stage is I need to work out my scale factor. And with that, we know that the scale factor is equal to your larger similar length divided by your smaller similar length. So which part of my triangle, left, right, or bottom, do I know both the lengths of? Well, in this case, it's the bottom, isn't it? So that 9 and 6. Okay, so to work out my scale factor, it's going to be 9 divided by 6. And 9 divided by 6 in this case, I think it's going to be similar, isn't it? 9 divided by 6 is equal to 3 over 2 again, which is equal to 1.5. Brilliant. And if I'm trying to find out, in this case, BC, which is this one here, this is the one I'm trying to find out. It's almost exactly the same, this question, isn't it? So this is the one I'm trying to find out, B to C. So to work out my larger similar side, I know that this one here is 1.5 times bigger, going from there to there, isn't it? So to work out my larger similar side, it's going to be my smaller similar side divided by the scale factor, which in this case is 1.5. So it's going to be equal to 5.2 times by 1.5, because we know that it's 1.5 times bigger. So 5.2 times by 1.5, which in this case is equal to 7.8. So B to C is equal to 7.8 centimetres. Super. Brilliant. Okay, so let's check those answers. Now notice that there was a past paper question worth 2 marks, okay? You've got to turn it round, don't forget that. But these questions do come up, alright? So 7.8 and 4.5, brilliant. Super. So let's have a look at another question now, okay? I'll make it big so you can see it. So get this down in your notes. This is example 3. We've got a few of these questions today. So, example 3. So we've got our shape here. And you might think to yourself again, Well, where are my similar shapes? Where are my two shapes which are the same? Okay, and you'd be right in thinking that because, yes, it doesn't look straight away like there are two shapes that are the same. So 2 and 8. Now, a lot of people, and this is crazy because obviously they're not even the same shape, break this up in half like that. So they've got a quadrilateral on one side and a triangle on the other, and then they try and work out similar shapes using those, doing 8 divided by 2, whatever it is. But that can't be right, okay? And the reason that can't be right is because you know that similar shapes have to be the same shape with the same angles, okay? Just one's bigger than the other. So you've got to make sure that you've got the right similar shapes here. So what we've got is, we don't split it up into the trapezium and the triangle. What we're splitting it up into is this triangle here, so this red triangle, which I'll draw in red, and my green triangle, which is the full big triangle going around like this. So this one here is your other similar shape there. So you've got one triangle, which is the green one, which I'll draw in green here. And it's always worth drawing these out again. And your second triangle this time is your red triangle. And it's all about that first part. As long as you know how to split it up, this just becomes like any other of those questions. So then we can start labeling. Now notice that the full length of this here, between 2 and 8, is going to be 10 across, isn't it? Okay. I don't know the height, but I know that's what I'm trying to find. This is x in this case. Now with the red one, the width of this is 8. And the height of this one is 5 there, like so. Brilliant. Okay. Same as always then. First thing I do is I find out my scale factor. And my scale factor is equal to my larger similar side divided by my smaller similar side. In this case, which one do I know the same of? Well, I know both the bottoms, don't I? So it's going to be that one there. So my scale factor is 10 divided by 8. So 10 divided by 8, which is 1.25. 1.25. Brilliant. So I know that this one here is 1.25 times bigger, isn't it? Because this one here is the smaller one, and this one here is bigger. So it's 1.25 times bigger. So in which case, to find out x, it's going to be 5. X is equal to 5 times by 1.25. 5 times 1.25 in this case is equal to 6.25. Brilliant. I think when you get to this stage, it becomes easy. It's just about knowing how to split it up. Okay. Now, this next one doesn't look similar, but it is very similar. So pause now and have a little go at that one on the right-hand side. Pause now and have a little go at that one on the right. Okay, so let's have a look at this one together then. So let's draw it out first. It's always worth drawing it out. I'm going to draw it in the same direction here. So what have we got? We've got a line across there. We know that this one here is 9 centimetres. This one here is 13.5. This one here is 17 centimetres. And this one here is 10 centimetres. These two are parallel. I've got A, B, C, D, and E. Brilliant. Okay. Now, I'm trying to find out the bottom length. So this C to E, which is there. And it's all about the way I split up these two shapes. It's not obviously not going to be a triangle and quadrilateral, but it is going to be this smaller triangle here, which I'll draw as red, and the larger triangle here. So the red triangle is kind of enclosed in that green triangle. So my red triangle there, let's label the sides I know. The left-hand side is 9 centimetres. The right-hand side here is 10 centimetres and the bottom is 17. The green triangle, which is the bigger one here, so this triangle here, from here to here is going to be the 9 plus 13.5, which is 22.5. Because look, it's all that length there, isn't it? That's what this green triangle is here. So 9 plus the 13.5, which is 22.5 centimetres. And if that's all I know, but I'm trying to find out this length here, which is C to E, which I'll call X. And again, once I've got to that stage, it becomes really easy. So I just really need to find out my scale factor first. My scale factor is my larger similar length divided by my smaller similar length. So which lengths do I know here? Well, it's only the left-hand side I know the both of. So it's 22.5 divided by 9. Okay, brilliant. So 22.5 divided by 9, which is equal to 2.5. So this one here, we know is 2.5 times bigger. So if I want to work out this bottom, I know it's 2.5 times bigger than that triangle on the left. So to work out, this one here is C to E, isn't it? It's going to be 17 times by 2.5. Because this one here is 17, and then we know that this one is 2.5 times bigger. So it's going to be 17 times by 2.5, which is equal to 42.5 centimetres. Brilliant. Now notice again that that's another past paper question. Okay, these do come up and they will. Usually it's about 2 or 3 marks, these, and there's like a different part that you need to work out next. I'll show you the next part in a second actually. So let's check those answers. 6.25 and 42.5, brilliant. Okay, so let's have a look at these next questions then. Let's make it big so you can get it down. So this one here is example 5. Now this one here is only a little bit harder, okay? It looks very similar, but the difference of this is, well, we'll see in a second. Let's draw it out first. Example 5. So we've got 2 parallel lines here. Super. We know this is X, 16, 10, and 13. Now, same as always, we need to draw out the 2 shapes, which is similar. So I've got this one here on the right-hand side, which is that smaller triangle. And I've got this one here, which is my larger triangle there, like so. So my red triangle, which is my smaller one, has got a height of 10 and a width of 13. Okay, and my green one has got a height of 16. And the width here is, I don't know, but I know that it's X plus 13. Okay, 13 plus the X. Brilliant. Now notice that that's the new part, isn't it? Because we're starting to do things algebraically now. So the X plus the 13. So the first thing I do always is to work out what a scale factor is, which is going to be my larger similar side divided by my smaller similar side. So my scale factor is equal to 16 divided by 10, which in this case is going to be equal to 1.6. So I know that this one here is 1.6 times bigger. That's fine. So that means I'm timesing by 1.6. But don't forget, this will work out the full length of this. Okay, not the X plus 13. So I do 13 times by 1.6. Let's write it down actually. 13 times by 1.6, which is equal to 20.8. So I know the full length of this is 20.8 centimetres. But remember, I'm not trying to find out that full length this time. I'm just trying to find out what this X is. I could draw it on here if I want. Let's show you that. This length here I now know is 20.8 centimetres. So if I know that that length's 20.8 and I know that that length there is 13, to work out X, it's going to be the 20.8 take away the 13. So 20.8 subtract this part here, which is 13. So 20.8 subtract 13, which is equal to 7.8 centimetres. Brilliant. Super. Okay. So let's let you have a go at that one on the right hand side. So pause now and have a little go at that one on the right. Okay, let's have a go at it together then. So I'll draw it out again. This one here is example 6 now. We've got a right angle there. That one coming up here. A right angle here. This one here is 14 centimeters. This height here is 4 centimeters. This one here is 7 centimeters. And I'm trying to find out, again, this shorter length here, which is the B to D. So I'll call it X for now. Now, the best way to do this always, when you've got an enclosed shape inside another, is to always draw them both out. So I've got my red shape here, and I've got my larger triangle, which is the full triangle there, like so. So with my red triangle there, let's draw it out. The bottom of that red triangle is 14. The height of that red triangle is 4. And then here, the green triangle, the width of that one, well, this one here is going to be that 14 plus x, isn't it? 14 plus that little bit there. And the height of this one is 7 centimeters. So the first thing I always need to do is to find that scale factor. In this case, I know both the right-hand side, so the 4 and the 7. So my scale factor is equal to my larger similar side, which is 7, divided by my smaller similar side, which is 4. So 7 divided by 4, which is equal to 1.75, like so. So I know that this is 1.75 times bigger. That's fine. So if I want to work out this length here, I do 14 times by 1.75. Oops. 14 times by 1.75. 14 times by 1.75, which is equal to 24.5. But remember, it's this full length here, which is 24.5. And I only want this little x part. All of that length is 24. So to find out x in this one, I do 24.5 minus 14. 24.5 subtract 14, which is equal to 10.5, which makes sense because 10.5 plus the 14 is the 24.5. So x is equal to 10.5. I'll just make that really clear. We know that that full length there, the full length of there is 24.5, don't we? So if I want to work out x, it's going to be 24.5, take away the 14. In this case, it's 10.5. Brilliant. Let's check that answer then. Again, 3 marks for that. Okay, from the OCR paper. Came up in 2018. Brilliant. Okay. So, I've got another question here. I'm going to put this up. I'm going to say pause now and have a go at this one yourself. This is a full past paper question here. So pause now and have a little go at that one yourself. So hopefully you've had a go at it. If not, if you're not too sure, I will go through it for you. So here we've got. Now, don't be worried about the fact that it's not a triangle. It's a weird shape because it says that they are similar. It says that they are 2 similar quadrilaterals. So we've just got one quadrilateral inside another one exactly the same way. This one here is 12. This one here is 9 centimeters. This one here is 8 centimeters. And this one here is 13.5 centimeters. So when I'm doing this, my 2 shapes are this smaller quadrilateral here inside, like that one, and this larger quadrilateral there, like so. So we've got this smaller quadrilateral here, there, and we've got the larger quadrilateral, which is the bigger one, there, like so. So let's write down everything we know. We know that this side is 9 centimeters and the bottom is 12 centimeters. This one here on the larger one, we know this right-hand side is, I'll do it in green so you can see it, is 13.5 centimeters. And the bottom is the 12 plus the 8. So 12 plus 8, which is equal to 20 centimetres. Fine. Great start. It's always worth drawing them out. So, for part A, it says find M to M. Now, I probably should have labelled all these, shouldn't I? So, P, L, M, Q, R, S, and N. So, M to N is here. So, this is the length I want to find. So, the first thing I need to do is, as always, find that scale factor. I know the bottom two similar lengths on this, so these are the ones I'm going to use. So it's going to be 20, larger similar side, divided by my smaller similar side, which is 12. So 20 divided by 12. So 20 divided by 12, which in this case is 1.6 recurring. Now, you've got to be really careful that a lot of people just round that to 1.7. I'm going to leave it as 5/3. Okay? So, what we're looking at now is we're trying to find this length here. So I'm going from larger to smaller. So if I'm going from larger to smaller, I know that it's 5/3 times smaller. Okay, so I'm going to be doing 13.5 because I'm going from larger to smaller. I'm dividing because it's that times smaller. I'm dividing by the scale factor. So divided by 5/3. Okay. So 13.5 divided by 5/3, which in this case is 8.1, which makes sense because it's smaller. Okay. It's got smaller. So I know that this length here is 8.1. And that's my first thing that I'm trying to find out, isn't it? M to N. So yeah, that went there. So this here is M to N. And then the next part says L to Q. Now, be careful with this one because L to Q is only this little part here, isn't it? So very similar to the last one, I know that that one there, that part there is 9 centimetres from there, don't I? Okay. So let's work out what the full length of this green one is first by doing 9, because I know this is my scale factor. I know it's 5.2 times, 5/3 times bigger. So to work out that full length, which is that, what's that? P to Q, that is, isn't it? The full length, P to Q, from P to Q, from P to L. So P, this is part A, I've done that. Part B, P to Q is equal to 9 times by 5/3. 9 times by 5/3, which is equal to 15 centimetres. Fine, that's okay. But remember, it's all of this length, which is 15. So to find out just this part here at the top, I need to do 15, take away the 9. And that's why this one here is the harder question. So the last little part, so P to L is 9 centimetres, P to Q is 15 centimetres, so L to Q is equal to 15, subtract 9, which is equal to 6 centimetres. Absolutely brilliant. So let's check both of those. 8.1, 6 centimetres, brilliant. Okay, just that extra little part, knowing that we found the full length, and then we've got to find that little part there. That's the tricky part, isn't it? Okay, so looking at this question here, we've got 2 questions left. Okay, now this one here looks straightforward. It looks like one of those easier ones that we did before, but it's actually not. Okay, now these don't come up very often, but I do want to go through them because they are tricky. Okay, this one here is example, I've lost count now, I think we're on example 8, I think it is. Now, it looks the same, doesn't it? It looks like one of those first ones. So here, we've got 4 here, 3 there, 3 there, and X there. And I'm going to draw them out the same as I did before. So I know this one here, like so. Okay. And I know this larger one here, which is the green one. Brilliant, fine. So let's draw the red one first. Now for the red one, I know the bottom is X. I know the left-hand side is 3. I know for the larger one, I know that the height is 4, and I know the left-hand side is x plus 3. Now, the reason this one is tricky, you might be able to spot it now, is yes, I can work out my scale factor by dividing those two, but I don't know either of those. So what you've got to do is you've got to create an equation, which is tricky here. Now, there's a few ways you could do it. You could use the fact that you know that these are the scale factors, or you can create an equation. So first of all, same as always, I'm always going to work out that scale factor, which is the larger similar side divided by my smaller similar side. So scale factor is equal to 4 divided by 3, and I'm just going to leave it like that, because it's 4 divided by 3 is going to be equal to 1.3 recurring, so it's a horrible decimal, so I do want to stay away from that. So I'm going to leave it like this. Okay. Now, the next part is tricky, because there's two ways you can do it. You can either create the equation, because I know that this times by 4 over 3 is equal to this, okay? Or you know that this divided by this is also the scale factor as well. Now I'm going to create the equation because I think that's probably the easiest way, okay? The problem is, I'll go back to it, we've got two things with unknowns in. We've got this x here and this x on this side, 3 plus x. But I know that this one here is 4 over 3 times bigger. So I know that x times by 4 over 3 is equal to this one here, which is 3 plus x. So that's why it's a little bit tricky, because you've actually got to form an equation here. So let's multiply this then. So x times 4 over 3 is equal to 4x over 3 is equal to 3 plus x. So now I need to go and solve this. Now this, again, as I said, it's pretty tricky, okay? We're getting a little bit harder here. So the first thing I need to do is to multiply by the 3. So it's going to be 4x is equal to 3 times by 3 is 9, plus 3 times by x is 3x. Okay? You always subtract the smallest unknown, which in this case is 3x. So 4x take away 3x is just x. 3x take away 3x is nothing, so I'm just left with x being equal to 9. That is tough, that, okay? Really tricky. You've got to form that equation. We've got the scale factor, and we know that the smaller side times by the scale factor is equal to your larger side. That's where we got this part here from. I'll just go through that again. So we know that the smaller side times by your scale factor is equal to your larger side. So your smaller side, which is x, times by your scale factor, which is 4 over 3, is equal to your larger side, which is x, and we create that equation. It's tough, that. It is tough. But that's why we've left it till the end, okay? Alright, so let's check that answer, make sure we've got it right. X is equal to 9, yeah, it is tricky, that, okay? So, we've got one more question to go through. Now, if I'm honest, I think this question is probably easier than the one we've just done. It's just to kind of round us off, just to push us that little bit further. So here it is. In fact, I'm definitely going to say that you should have a go at this one yourself first. So pause now and have a little go at that yourself. I think you should be fine with this. Okay, so let's go through it together then. So this is just a full question, just taking it that little bit further. So we've got 4.5 on the left, we've got 6 on the right, we've got 4 here, 4 centimetres like so. This one here is 4.8, and it asks for, calculate the perimeter. Let's write them down. So A, B, C, D, E, and it says calculate the perimeter of the trapezium at the bottom, so this part here, okay? So, the same starting point as every single one of these. The first thing I'm going to do is I'm going to draw out the two shapes. So I've got a smaller triangle here. Now notice with this one, the reason this is tricky is it doesn't say that it's similar shapes. Okay, you've got to know that because those two lines are parallel, they are similar. It doesn't even say find out the bottom length, does it? It says find out the perimeter, so I'm going to have to find out this one and this one, okay? So I've got this the top triangle here, which I know quite a lot on, don't I? I know that the left-hand side is 4.5. I know the right-hand side is 6. I know the bottom is 4.8. Now the larger triangle is where I don't know things. So the larger triangle there, the right-hand side, the full length of that is this 6 and 4, which is going to be 10 centimetres. And that's all I actually know, isn't it? Okay. So I need to work out the perimeter of this. I need this, 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 and this. Now, I don't know the C to B to C, and I don't know C to D either. I don't know either of those. So I've got to work out this bottom, and I've got to work out this one. And then once I've got those, I can add them all together. So I think the easiest thing to do is to work out the bottom one first. So let's call that X if you want. You can call it whatever you want. But we do that by finding out the scale factor always. Same as always. It's your larger similar side, which is 10, divided by your smaller similar side, which is 6. 10 divided by 6 is equal to 1.6 recurring. I'm going to keep it as 5 over 3. So I know that this one here is 5.3 times bigger. So to work out the bottom here, I'm going to times 4.8 times by 5 over 3. Brilliant. So this bottom is 4.8. Let's show the examiner we know what we're doing. Times by 5 over 3, which in this case is equal to 8. So the bottom here is 8 centimetres. Brilliant. So I know now that this bottom is 8 centimetres. We're getting there. Now, remember, we can't work out similar shapes in terms of this trapezium. We've got to work out what the full length of this is and then take away this part here, which we know is 4.5. Okay? So to work out the full length, it's going to be the 4.5, again, times by my scale factor, which in this case is 5 over 3. So 4.5 times by 5 over 3, which is this full length here is, in fact, let's just show the examiner, 4.5 times by 5 over 3, which is equal to 7.5. So this full length here is equal to 7.5 centimetres there. But remember, I don't want that full length there. I only want this part here, okay? So I know that this full length is 7.5. I know the top is 4.5. So to work out this bottom, it's 7.5 subtract 4.5. 7.5 subtract 4.5, which is equal to 3. Have I finished? No, I haven't. All I know is that this side is now 3. So to work out the perimeter, I need to work out all of those added together. So it's going to be this, plus this, plus this, plus this. That's the perimeter, isn't it? So we'll do all of those. It's on the left, 3 centimetres, plus the top, 4.8, plus the right, 4, plus the bottom, 8. 3 plus 4.8 plus 4 plus 8 is equal to 19.8 centimetres. Brilliant. And we're finished. Alright, let's just check that. Let's make sure we got it right. 19.8, brilliant. Super. Okay. So, I've got some questions here. I'm going to make it big for you to have a go at. So pause now and have a go at those questions. Pause now and have a go at those. Okay, I'm going to pop the answers on, so mark those in green. Brilliant. So thank you for watching this video on similar shapes. Do make sure you're having a go at these questions, because remember, the only way to learn maths is to do it, and have a lovely day.